Good afternoon, everyone. Good afternoon, Yanshika, Thakurdas, Jigyasu, Pranshu. Good afternoon, Vanshika, Harsh, Meyansh. So, yesterday, as we have completed the exercise, so today we are going to start with the last uh, part of this chapter, which is based on Pythagoras theorem. This week, by Friday, I need all the notebooks. Otherwise, internals will be affected badly. You should take care of these things. Last date is this Friday. Submission is this coming Friday. That is 14th August. Yes, Nishant, you have sent. Yeah, those who have not sent chapter number 6, they can send now chapter number 6 also. And this week your notebook is accepted from chapter number 1 to 5. Okay, and 6 if you want to send later, means the next week you can send in the next week. Doesn't matter. 1 to 5 at least I want. At least 1 to 5 chapters. Okay, starting with this theorem. If a perpendicular is drawn, see it carefully now. If a perpendicular is drawn from vertex of right triangle the hypotenuse, then triangles on both sides are perpendicular of the perpendicular are similar to each other and to the whole triangle. What is this all about? Your syllabus for September will be only 1 to 7 chapters. From chapter number 1 to 7, this is your syllabus for September. It is afternoon, Yuvraj. Okay, now students are already have joined, so let us start. If a perpendicular is drawn from the vertex of a right triangle, let me make a right triangle first of all. So I've made here a right triangle. Yes, Daljit ma'am, it is chapter number 6, the same going on, and today we are doing exercise 6.5. And before starting with exercise 6.5, we are doing these theorems. Yeah. So let me say there is a triangle ABC. I am explaining this theorem to you. There is no need for any proving of this theorem. Only you should know this theorem. It will help us to solve many questions. If a perpendicular is drawn from vertex of a right angle, triangle. So first of all, I have made a right angle triangle, and which is right angle at B. Now I am making a perpendicular from the vertex of a right angle. So where is a right angle? Right angle is here. I am making a perpendicular from this side. I am making a perpendicular from this vertex. Now this is a perpendicular, so it will make here 90 degree. So again, if a perpendicular means this perpendicular is drawn from a vertex of a right angle, means from which point we have to draw? From right angle. So from a right angle, I have drawn a perpendicular, a right angle triangle, and this perpendicular is landing on this hypotenuse AC. Then the triangles on both sides will be similar to each other, and triangles on both sides means this triangle and this triangle will be similar to each other, and these two triangles will be similar to the whole triangle. This is the theorem. So in right triangle ABC, right angle at B, just note it down in your notebook. You should know this theorem. We're going to use this. Right angle triangle ABC, right angled at B. If this is the condition, and we have drawn from point B a BD perpendicular to AC, and from point B we have drawn a perpendicular, and the perpendicular is falling on the hypotenuse AC. AC is the hypotenuse because AC is in front of this 90 degree. So in triangle ABC, AC is hypotenuse. So this perpendicular is falling on the hypotenuse AC. Then triangle on both sides, triangle ABD, it's similar to triangle CBD. Okay, and one more thing, triangle ABD will be similar to triangle ABC also, and triangle CBD also will be similar to triangle ABC. Note it down. So what I have written, if this will be given in a question, then directly we can write this theorem. In the solution, we can write this theorem, and afterwards we can write these things. It is useful. Means ABD means this triangle will be similar to this, and this triangle will be similar to the whole triangle, and this triangle also will be similar to the whole triangle. So all these triangles will be similar to each other. Simple. So how to use this theorem further? Note it down. We are moving on to then next. Yes, good afternoon, Ravinder sir. Note it down, students. Yuvraj asked me on WhatsApp, I'll send you the detail. Okay. Now after this, starting with the proving of Pythagoras theorem. As I have told you that this exercise is based on this theorem. So, and the proving of this theorem is also important, and it is in the syllabus. The proving is in the syllabus of Pythagoras theorem. So we are going to prove this now. In this chapter, we have proved till now basic proportionality theorem, the Thales theorem, BPT, and converse of BPT. After that, we have not proved any theorem in between. And after that, we have this last theorem left, which we have to prove, as this is the proving in there in our syllabus. So starting with this Pythagoras theorem. In a right triangle, Square of the hypotenuse, we know this, that Pythagoras theorem is this. Now in this we are going to prove this, how hypotenuse square will be equal to perpendicular square plus base square. The square of the hypotenuse is equal to sum of the square of other two sides. The square of the hypotenuse is equal to sum of the square of other two sides, and other two sides are perpendicular and base, making a triangle, a right angle triangle. So it is made right angled at B. So let ABC be a right angle triangle. Okay, Raj. So most of the students are without video. Daljit ma'am marked absent today. These students, those who are without video, no need to put present. Simple, mark absent. So a perpendicular is constructed on this. What is given, first of all, right? It is given that triangle ABC is right angled wait a second. Screen sharing is stopped in between. Is it visible? Stopped in between. Screen sharing and all. Okay, then. The screen is visible to you? Yes, okay. Given triangle ABC, right angled at B. So there is a triangle ABC, which is a right angle triangle and right angle at B. Nothing else is given. What we have to prove? We have to prove that AC square, this is the hypotenuse in front of 90 degree. So AC square is equal to AB square plus BC square. So there is a sequence in this. If you will be able to understand the sequence, you will be able to prove this theorem very easily. Construction, draw BD perpendicular to AC. Proof. Starting with the theorem which we have written before this, the same theorem we are going to use now. If a perpendicular is drawn from vertex of right angle in right angle triangle, then triangles on both sides of perpendicular are similar to each other and to whole triangle. After writing this, after writing these three lines or four lines, you will be able to write directly that these triangles are similar to each other. Which triangle? If a triangle I have written, if a perpendicular is drawn from a vertex of a right angle in a right angle triangle, then triangles on both sides means of this perpendicular, this side and this side, if you will see ADB and BCD will be similar to each other, and these two triangles are similar to the whole triangle also. Therefore, we can say that triangle ADB is similar to triangle ABC. Okay, now see this, how I have named the triangle, which is very important. This, see this, one triangle I have taken this, that's ADB, and one triangle I have taken this ABC full. Now see this, how I have named the triangle. This is triangle ADB. I have started from A, then I moved to the 90-degree angle, then B. So it is ADB. Now how to name this ABC? I have started from A, I have moved to the 90-degree angle, then C. So if you will name them in this way, it will be easy for you to prove. If you will concentrate on what I have written here, then it is easy to prove further. The moment you have written that ADB and ABC are similar, then we can say that AD upon AB is equal to AB upon AC. That is sequence. Try to understand this, what I am saying. AD upon AB. Otherwise, no students used to forget that, sir, what are the sides which we have to write here? So you can write from this side only. That AD, the first two, and this is the first side. The first side is AD, and here the first side is AB. So AD upon AB is equals to then AB upon AC. Learn this sequence. It will help you to prove the theorem very easily. AD upon AB is equal to AB upon AC. And that's why I'm saying that naming is very important. Starting from A, then a right angle triangle, right angle, then B. So ADB, starting from A, then a right angle, then C, then ABC. So this is done. Let it be equation 1, and right here CPST, because angles are similar, so sides can be proportional to each other. Similarly, we can write triangle, this one, that's BDC. It's also similar to ABC. So how I am naming this? B, left, B, then right angle, then C, angle BDC, similar to triangle A, then right angle, then C, ABC. Let it be second equation. What second? After this. Not this. Now, how to name last two now? Initially, we have taken the first two. Now we are taking the last two. So just write here on this basis, DC upon BC is equals to, this is same, BC upon AC. This sequence is same, the way we have done here. But the first sequence is changed. See this here, AD upon AB, the first two, here, the last two, DC upon BC. And this is also by CPST. And from first and second, we can prove further. I have not written one step. Just write that also in between. Wait. Wait a second. I have not written here the one step. Here I have not cross multiplied. You have to cross multiply here. AB into AB will be AB square, and AD into AC will be AD into AC only. And make this your first equation. Otherwise, later on also we have to write the same. So do it here only. And here also like this, cross multiply here only. Then BC into BC will be BC square, and here will be DC into AC. Again, see the proving of the theorem again one more time. As we have used the theorem which I have explained here, after writing this theorem we can say that ADB and ABC are similar. After that, this sequence just you can also mark your solution in your notebook so that you will be able to understand how to take these sides and which side we should take. First two and the first last, like this we can make this, and after that cross multiply AB square equals to AD into AC. Then again we have taken the other triangle BDC and the whole triangle ABC. Here now we have taken the last two DC upon BC and BC upon AC. Then cross multiply again, then BC square equals to DC into AC. If we will add them, then we will be able to prove. Add 1 and second. Bachika, you are laughing and talking, you are not sitting properly. Add 1 and 2. AB square plus BC square is equal to AD into AC plus DC into AC. See this? AB square plus BC square, left side also we have added and right side also we have added. Now in right side, no, we can take AC common. It will left with AD plus DC. Now AB square plus BC square is equal to AC into what is AD plus DC? See in the figure. AD plus DC is full AC. So we can write here in place of AD plus DC, AC. So AC into AC will be AC square. So this is proved. That's only we have to prove. Hypotenuse square equals to perpendicular square plus base square. Note it down. If you have any confusion, if you want to ask anything, you can ask. After this, next, inverse of Pythagoras. We are not going to prove this as it is now. The proving is out of syllabus, so only theorem will be useful in our solution. So that's why we are just studying this theorem. In a triangle, square of one side is equal to the sum of the square of other two sides. Now this is just converse of Pythagoras. If h square is equal to p square plus b square, then that triangle will be or we can say that triangle will be a right angle triangle. Simple. If this is already given in the question, then we can say by converse of Pythagoras that triangle will be a right angle triangle, or the triangle opposite to hypotenuse will be a right angle. We can say like this. So this theorem will be able to use directly. There is no need to prove this. Just you can write in your notebook that this is converse of Pythagoras. That in a right angle triangle, if I am talking about a right angle triangle, and if it's like this, if AB square, this hypotenuse, AB square is equal to AC plus BC, means this will be given in advance in the question. If this is given, it means angle C is 90 degree. Okay, means if this is given, then angle C, it means it is 90 degree, simple. This is only converse of Pythagoras. You can write this, else nothing to write. You can write this only. After this, moving on to the exercise. Let us do some questions based on these theorems. Exercise 6.5. Sides of triangles are given below. These are the sides of the triangle. You have to determine. Okay, you want to write it down. Once you have written, then tell me. Okay, done. Okay, then moving further to the next. Exercise 6.5, question number 1. Sides of triangles are given below. To determine, are these the sides of right angle? And what is the length of the hypotenuse? How we can check that these sides are the sides of a right angle triangle? For this, we will use the Pythagoras theorem. 7 centimeter, 24 centimeter, and 25 centimeter. These are the sides given. So what is the longest among them? 25. So let us take out the square of 25. 625. And then let us take out the square of 7 and 24 together. That will be 49 plus 576. And this is 625. Since here 25 square is equal to 7 square plus 24 square, therefore by inverse of Pythagoras, which theorem we have to use here? By converse of Pythagoras, because h square equals to p square plus b square. It is like this. We can write like 7 centimeter, 24 centimeter, or you can write directly these sides. These are the sides of right angle triangle. These are sides of right triangle. And hypotenuse is 25 centimeter. This also we have to mention. This way we can do all these parts. So let us do one more part. Is 3, 8, and 6. I'm doing only 2 parts of this. As you can check, is 3, 8, and 6. So 3 centimeter, 8 centimeter, and 6 centimeter. So here the longest is 8. So 8 square is 64. Then we can check out the square of 3 and 6 together. That is 9 plus 36. It is 45. Since 8 square is not equals to 3 square plus 6 square, therefore these are not the sides of right angle. That's it. If these are the sides of right triangle, then we have to tell the side of the hypotenuse, means length of the hypotenuse, and hypotenuse we know that is the longest. That's why h is 25 here. And this side we do not have this equation equal. If this equation is not equal, then we'll write that these are not the sides of right triangle. Simple. So this is over. Here's first question is over here, and in the same way you can do the third and fourth part. So this is done. Note it down. We'll move to the next. Question number 2. PQR is a right triangle at P, and M is the point on QR. Okay, let us make a right triangle. So right triangle PQR, Q, P, and R, and right angle at P. M is a point on QR, so M there is a point on QR, such that PM is perpendicular to QR. Okay, PM is made perpendicular to QR. So right in question number 2, what is given? Given PM perpendicular to QR and triangle PQR is right angle triangle and right angle at P. Okay, then to prove PM square is equal to QM into MR. See this, this PM, QM, MR. Just check this. QN and MR are the part of which triangle? QM is the part of this triangle, and MR is the part of this triangle. See this. QM is the part of this triangle, and MR is a part of this triangle. So we have to prove that these two triangles are similar. So how we can prove this? That these two triangles are similar? With the help of same theorem you can prove. Same theorem. Since perpendicular on from vertex of right angle of right angle triangle, then perpendicular triangles. We can write here that then triangles on both sides of perpendicular are similar to each other. Okay, therefore, in this way, we can say that triangle PQM or PQM is similar to triangle PRM. If these two triangles are similar, then we can write something like this. See this, how prove this. I'm writing this in rough here. PM square equals to QM into MR. PM can be written as PM into PM is equals to QM into MR. Okay, I'm just assembling it. PM I've written this side, and QM I'm writing in the denominator this side, and MR I have written this side, and PM I am bringing this side. So if you are able to prove this, then we can prove this also, because by cross multiply we can prove this. Okay, you have to break the proving part in this way, then you can write the fraction form, and from the fraction form you will be able to know that this only we have to prove. You can write here PM upon QM. You can check out PM upon QM is equal to MR upon PM, and these will be the part of this triangle only. PM, PM, QM, and MR and PM. These are the only parts of these two triangles. So by cross multiply, we can say that PM square is equal to QM into MR, hence proved. And this by CBSE you can write here. Note it down. Only one theorem which we have studied today, the very first theorem. After that, PQM and PMR, PRM are similar. After the similarity, we can write the corresponding sides are in the same proportion. If the corresponding sides are proportional, then we can cross multiply and we can prove the same. And how we have written this only by to write these sides, and this sides you will be able to know by using what we have to prove. See this, we have to prove that PM square equals to QM into MR. So PM we have to divide into two parts, PM into PM. It is PM squared now, so PM into PM is equals to QM into MR. Then keep this PM here and bring this QM this side. Keep this MR here and bring this PM this side, and make this kind of fraction, equal fractions, and the right same thing here by CPSC. Then cross multiply and prove. That's it. Much only you have to do in equation. And rest of the questions we will be doing tomorrow. At last, we are at the last exercise of the chapter. The chapter took so long. Still, it will take time. Okay, then bye. Take care. What are you asking? Please show first time we have done today. Good question, Samreen. I'll ask from the central government and I'll answer you. Okay, bye.